Hi, everyone. Welcome to this special edition podcast with our very special guest, Ladyada Freed. Uh, I'm Abram Pilch, as editor in chief of Tom's Hardware, with associate editor Les Pounder, and we're here to talk about something really cool and special that Limor has been working on involving AI and coding. So, what is going on?
Hello. Okay. Well, we were chit chatting a little bit before the video went live, and you're like, how's your baby?" And my baby's still alive, which is like pretty cool. And having my time has been really changed ever since I had a kid. Like I still manage this company of about 100 people, and I'm the CEO, and I'm like trying to do technical decisions. But what I don't have is like big chunks of time. And one thing that I used to do all the time was write Arduino libraries, which also runs on the Pico, and the code ends up getting ported to CircuitPython, which runs on the Raspberry Pi. So it is thematic. It's thematic. It's on the theme of Raspberry Pi and Pi products. Um, but I just don't have that like 6 hour chunk. Like when you want to really write like a library, you have to get in there and you read the full data sheet, and then you just like sit down and you're like 6 to 8 hours of like solid context aware coding, because you have to keep all the registers in your head and like how what order they're in and the bits, and it's a lot of busy work. And Mr. Ladyada, who's eating and hanging out, was like, oh, have you tried using Copilot or ChatGPT for some of this work?
Mhm.
Apparently, everyone uses Copilot. I actually don't use Copilot. I mean, it's actually pretty good, but I've tried with VS Code, and it's good for like auto completion of stuff, but it's not good at creating new code. Like if you're writing the code and it's like it really is your co-pilot. Like you're driving and they're there next to you and they're like, oh, hey, they have the map open and they're like, take a left on Route 6, and oh, wait, like stop here. Let's go get some coffee. What it isn't good is this like whole synthesis. And so I signed up for ChatGPT 4, which is the latest in the large language model. And I'm sure like
Mhm.
Llama can do some of the stuff too. I just happen to only be using GPT-4. And it really improved, especially since August 3rd, where it has this ability where I can have a plugin that I upload the data sheet for the chip that I want to code for. And then it reads that into the context, and I can have it write code based on the register maps and the information, the data inside of the data sheet,
Mhm.
particularly the very tedious stuff of like making enumerations for every option of every bit field, the pound defines for every register, like the default values, and then I can have it start doing setters and getters. And because it has this full context, unlike Copilot, which I don't think does a full context of every file you have, or at least I can figure out how to get it done, is then, after I'm done with all the code, I'm like, okay, generate the header files, and it'll put all the prototypes in, and I can say,
Mhm.
add the doction commentary based on what the datasheet says each register does, and it will do that for me. And it's kind of like creating huge chunks of code, these like functions that I can then use to make a library. Is it perfect? No. Does it make mistakes? Yes. Do you have to look at everything it generates to make sure it's correct and get it back on the path? Sometimes. But 90% of the code, I only had to do it a couple times. 90% of the code,
Yeah.
especially once I get it on the right track, can like pop out whole functions. And so over the long weekend, it was a long weekend. So I got to spend some time actually playing with, and I got much better. Like the first time was like really clunky. Like the first time I didn't
Mhm.
realize you could upload a PDF. So I was actually copying and pasting chunks of the PDF into the chat window. And then Phil's like, oh, there's a way you can upload a PDF. And I was like, but there's no way it's going to be able to parse a table. And it's like, actually, it can. It can parse all the weird ass tables with like inset pieces and text, and use that to grab information out of, and generate whole header files or whole functions out of. And so I'm getting better and better at it. And I'm starting to get back to some old boards that I haven't had time to get to for the last 9 months or so. And then um, what I'm doing is, as I'm publishing the libraries, I'm putting in the chat logs so people can follow along.
Mhm.
I don't believe in this, like the prompt is secret and like you have to prompt the engineer. It's like you can see, and like I make mistakes and I tell it, like I correct it and I go back and forth. And then I'm starting to kind of actually come up with the like copy and paste like prompt introduction, so you can set the stage for the large language model to know what you want. But the cool thing is that it's clearly been trained on hundreds and hundreds of libraries that I've written over the last decade plus. So I'm not. It's actually like I'm just telling it, hey, could you write the way I would write? And it's a great mini me. It's like me as an intern. You know what I
Right.
mean? I'm like a very positive intern. Like I can do the work and make mistakes, but like I can read the data sheet, parse it, update it, and for this kind of
Yeah.
very repetitive work, it's great. I think.
How do you feel about OpenAI kind of using your work this way?
You know, I think it's fine. Like all my code is under an MIT license, but I will say that, you know, and I don't know, like it's of course up to the courts to figure out like what is the boundaries and legalities. I know that there are some plugins that'll tell you where it got the information from, but the code it's writing, like when you know the code that I'm writing, it's not. I want to say like it's complicated, but it's like it's like de minimis. It's like you're setting up a register. The hard part is parsing that PDF to get that data out. Like, what is the register address? What is the default value? What are all the options for this bit field? Because, you know, like each chip register has like, it's, you know, 8 to 16 bits and it's like sliced up in like weird ass ways. And you have to get in and just change like 2 bits. Um, I think it's, you know, it's an interesting future, but I also don't think like we can really go back. The good news is that all the code I've written is under like a very permissive MIT license. So I think if people, you know, I think right now the best option is if people are using my code or like the prompt that's like write it in her style. I think just do what I did, which is you say, hey, credit goes to, you know, you do like a license
Yeah.
attribution. And like my solution is I just say, here's the chat. And you can see me talking to the language model to get it to write this code. And I'm, you know, telling it um, kind of line by line sometimes, like, oh no, change this, change that. And once it gets a hang of it, it does it repeatedly.
Mhm. That's what I like in the video. You're explaining what's going on in a way that we can all understand. I know a little about Arduino, nothing about writing drivers or libraries at all. It's all
It's really
dark
hard, and that
science.
the trick is, it's like if other people do this, it's like good for me, right? Because I don't want to write all these drivers. I'm tired of it. Just why I'm using a language model, right? So, ideally, if other people like that's a good idea, and they use the prompts I use to get
Yeah,
it to write drivers for other chips, that's great for everybody because like I would love to see more well-written drivers, and I think the drivers I write are well written and well documented. So if people can follow that style, like everybody wins.
Yeah, fair enough.
yeah.
So, what have you used it for? What are some of the best things you used it for?
Okay, so it's only been like 3 days, okay? So, like, it's very new. But the first thing I used it for, and I still have this on my desk. Sorry, one second. Okay, so the first one is this HUSB 238. It's not, you're not going to be able to really see it. It's the HUSB 238 USB-C power delivery chip. So it's got USB-C in, and then there's this chip here, and then these pins where you can get power out. And this is a chip that can connect to power outlets like this one. This is like a USB-C, like chunky power outlet. It's so chunky, it's like it's still the LED is still lit, even though I unplugged it. It's like still alive. And this one can provide, you know, 5, 9, 12, 15
Hmm.
volts at 20 volts at up to 3 or 5 amps. So it's like a big, it's like a, you know, can do a power supply. Laptop power supply. And a lot of people have like projects or robotics where they want to get, they're like, oh, I want 100 watts, 12 volts, 5 amps, or maybe I want 20 volts, 5 amps, and I buck it down to get like 50 amps at 5 volts if you're like willing to do a big power supply. And, you know, these are very, very inexpensive and easy to get, cheaper than a Meanwell, and safer too. There's no exposed wiring.
True.
So you would use something like the HUSB 238 to you convince this power adapter to give you the 20 volts. And it's one of those chips where there's just a lot of registers and like a lot of bits you have to set, and it's very repetitive. So I did that one. I also did the VCNL 4020, which is a light and proximity sensor. And this is an update to the 4010, which I think we have in the shop, but that chip got discontinued. This is like the next gen, and it's like for infrared proximity detection. And this one also had like a ton of registers, so like all the little
Hmm.
tweaks and settings and how much current and like, you know, frequencies and sampling rates and stuff. So I did that library, and then I think the third one I did was the. Sorry, I'm looking at my desk. Everything looks the same. It's all circuit board shaped. Weird, huh?
That's a
Uh,
great desk.
yeah, it is a great desk. I did. I don't have a secondary one. I did the INA 3221, which is a triple voltage battery power monitoring chip. Which also has a lot of knobs and switches. And, this one was actually interesting. This is the last one I did. And this is when I started learning that when I do some of the prompts to ChatGPT 4, ironically, sometimes you want to be specific, but sometimes being vague actually gave it, I don't want to say like more freedom, but it was able to, like I would just sort of I would start like not being specific about what I wanted. I'd say, oh, just write a getter and a setter for this threshold voltage, and it would actually kind of fill in everything on its own. And one thing that was interesting to see is in this chip, there's 3 channels. You can see like there's three different power channels, and it can read them all simultaneously. And one of the annoying things about the register map, and this, like I've had this in other chips, sometimes the registers are 1, 2, 3 in order, and sometimes they're 3, 2, 1 in order. So like, there's like 3 bits, and sometimes the bits are 1, 2, 3 ordered, and sometimes they're 3, 2, 1, and it's not always consistent. Sometimes it's one way, sometimes the other. And this is exactly where a human makes a lot of typos, a lot of mistakes, where you're like, oh, I'm just going to assume it's always going to be, bit width plus channel number, and that would get you 0, 1, 2. But what you really want to do is channel bit width minus the channel number, because you want to go backwards from 1, 2, 3. And what's interesting is ChatGPT 4 was actually able to, when it parsed the data sheet, recognize when it did one or the other. And so there were sometimes I was like, oh, wait, you made a mistake. And then I looked at the data sheet. I'm like, oh, you were right. And I was wrong. It's kind of creepy.
Yeah, that makes sense. I mean, it is, under the best circumstances, it's a machine, so it's going to remember things. It's going to remember the details.
Yeah, it's just interesting. PDFs are, it's just so hard to parse. I'm kind of impressed. And I think that's what the power is, because a lot of people, since I've said, hey, I'm doing this, are like, why aren't you using Copilot? And the thing, actually went and tried Copilot today, because I was like, fine, I'll try it, even though I tried it before. And it's good for code completion, but it's not good for generating whole chunks of code, like full complete, here's the entire function. Like, definitely will tab complete and will kind of guess what you want to do next. But I found that maybe it's because it's using GPT-4 or 3 or like this earlier version. But if you upgrade to GPT-4, it actually does give you a lot more data. So it's super fun. You like upload the PDF, and then you just start telling it like, hey, here's what I want you to do. And you just have to understand the context window isn't that big. It's going to start forgetting things. So you do have to kind of get straight to work. Like, you can't be like, how are you doing today? You have to be like, all right, start.
Yeah,
da, 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 da. And also, like, I like to be polite, but you want to be, because you have to give it positive reinforcement when it did the right thing, so it knows to continue in that style. But you only have 50 messages every 3 hours, and which is exactly as many as you need to write a driver, as long as you don't do too many back and forths.
So what plugin are you using in GPT-4?
I'm using right now the AI. It's called AI PDF. It's like the PDF importer. So I can show you. I don't know if you guys, I could share like a screen.
Yeah, I'd love to see that.
Yeah.
Okay, we have a few minutes. Hold on, I gotta learn how to do this.
Yeah, I saw in the video you were sort of copying and pasting bits from data sheet, saying start here, end here. And I was just blown away that it could do something like that.
Yeah. Okay. So I don't know if you guys can. You guys have to bring it in, I think. But you can. Yeah, you can hide us. So I'll hide this with some more text. And is it? Let me see. Is that big enough to read?
Yes, definitely.
Okay, great.
Yep.
The only thing is the little like scroll bar is so tiny. So I start with this big prompt, and I'm still working on this prompt where I kind of say like, I want you to write it in this style. We're gonna do this, and I want you to use the PDF to get data out, and then I want you to use this. I have to give it the function prototypes, because it's like, it would sometimes mess up the argument order. And so I'm like, hey, here's the function prototypes I'm going to use for the main register creators. And then I'm like, okay, great. And then I'm like, also, by the way, like, you don't need to, otherwise it likes to explain everything it did in detail. And I'm like, please don't, because it does take time.
Right.
And after that, I basically just uploaded the PDF, and I said, I want you to start by creating the chip name, register name, address list, which is extremely common whenever you do a driver, is you have to and there can be like 30 of these, and you have to like kind of hand write them. And it popped it out. Like that's the first thing it popped out is like, okay, here's the beginning. But it did miss a couple, which was interesting. So at the beginning, I usually have to say like, hey, you forgot some, and then it kind of like it gets a little confused, and then I can't try again. And then at the end, it's like, okay, I got it. So I noticed that the first few questions I have to kind of, no matter how good my first prompt is, I have to kind of like massage it into getting what I want.
Mm-hmm.
But then once I do that, I'm like, okay, now create the header file. It creates the full file for me. And then the first time I do like a register getter, so it's a very common thing again, is you say like, there is this data in a register, and I want you to make me a function that will reach in, take that data, and format it back for me. So I do kind of spell it out. And I also say, include documentation. And I give it a reminder. Although it's interesting, I might not have needed to give you the reminder. But it pops out the entire code. And then I kind of, again, I kind of like lead it through like, okay, I want you to have it be a member variable in this class. But then once I get it started, I'm like, this is kind of the power move. I say, okay, do the same for this next register, and it will duplicate the work. So then I don't have to, it does it correctly the second time. And then I'm like, okay, write the begin function. And one trick I learned is that I give it the prototype of what I want. And that it helps it, instead of just being like, write me a begin function, I'm like, here's what I want the prototype to be. It tells it what arguments it's going to use, and then of course it tells it what data it's going to return. So I'll skip down because it's it's a little bit boring. You can read the whole thing. Okay, so this is actually where I got kind of interesting, because the first few registers are very basic. I get it started with like, there's just read this register data, but then I say, okay, I want you to write this new function and do some data checking. And then you have to figure out which register it is, because there's 3 registers that you pick, different ones for each channel. And it correctly identifies them, and it handles the case that, it starts at 0, but the name in the register map is 1. So it does the smart thing. It's like, oh, 0 is 1, 1 is 2, 2 is 3. It returns 0 here. The rest of this is fine, and it handles this bit shifting. And then I'm like, oh, hey, by the way, I want you to return not a number, and it does the correct thing, and it also updates the oxygen at the same time. So it's interesting, because you're kind of playing with this putty. In the beginning, it's like kind of nebulous, and you sort of have to get it into this shape. But once it's in the right shape, as I continue, I'm like, okay, do the same for this next one. And it not only does it basically write the same function, but it then gets the correct different register values. It remembers that I wanted it to return NaN on invalid. And it does like the math to convert the value. I think here, this one was 40 microamps per LSB. And this one, I was like, oh, hey, this one is going to be 8 millivolts. And it does the right thing. It's like, oh, you have to multiply by 8 millivolts to get the actual voltage out. And then by the end, I can actually just sort of say, just write this function, and it will recognize the register and get me that data, and also handle any errors. So you do have to train it. But I post these chats again with all the libraries I've written. This one isn't published yet because it's not complete. But people can follow along. I feel like I'm chatting a lot in this video, but I don't know, maybe that's okay.
That's great. One thing, so what I take away from this is that you had to spend a lot of energy describing what you wanted.
You do have to describe it, but the thing is that it's English, and it's just directional. I find it a lot easier, especially since I have carpal tunnel. It's a lot easier for me to have my keys on a keyboard, and I'm giving it English written instructions, than to do the copy and paste work that the heavy mousing and flipping back to the data sheet. So what I do is usually I have OpenAI in one window and the chat going, and then I have the data sheet in the other, because I'm going literally through the data sheet page by page, to write the driver for each page in the data sheet. And so as it's generating these, I can because the typing, when it generates it, it doesn't it kind of writes out each line, like you can sort of see it do the typing.
Yeah.
So you can, as it's typing, I'm like quickly being like, okay, is that value correct? Is that value correct? Is that value correct? But it's not it's again, it's not like generate complete driver. I don't know what would happen if you type that. I don't think it'd be very good.
No, it wouldn't, because you have to be very
No.
specific.
You do have to be very specific. So it's good for people who've like managed other folks, I think, because you know how to be like, oh, I see where you made that mistake, and then you can correct it. But that, you give it that first function, and then I'm like, do the same for this, do the same for that. It goes and it does it. That's, I think, powerful, because one thing that happens when you have beginners is that you're like, when you say do the same for this other register, they'll copy that text, paste it, and then try to go in and edit, which is where all the mistakes come in, because they always miss one thing,
Yeah,
or
no doubt.
they don't realize, oh no, you have to multiply by 8, not 40. This is like, so like I've taught so many people how to write drivers that I've seen this over and over and over again. It's fairly smooth, and at the end, I can tell it. I don't think I did here, but I'm like, okay, like other details, like, okay, I want you to update the Doxygen to list all possible flags. It'll parse out this and then add it to the Doxygen. Like, Doxygen commenting takes so long. It handles all these registers, and at the end, I think I was like, okay, give me. I changed, one thing I changed is because there's 3 channels. I had a member variable, and then later I was like, oh, I want it to be an array of 3 values, so you have a different resistance per value. And I was like, go back and update all the functions that reference this value, and go back and update it to, now it has to index into an array. And it was like, okay, here's all the functions that have been updated. And then I'm like, and what's nice is it keeps all the context. So at the end, I'm like, okay, give me the header file with all the function prototypes in it, and it pops it all out. Again, it's like, you can do it by hand, but it's a little tedious. And then there's tools to help you, but it's still nice that it pops it all out at once. And then I have it write a constructor for me. I'm like, okay, have the setup, and you can see I start writing shorter words. I'm like, check the menu. I don't say check the manufacturer ID, get open paren. I just say like I kind of have vague commands, but it recognizes what I want. And then I'm like, okay, now write the Arduino sketch. And I tell it what I want it to do. And I'm like, okay, display the current in milliamps for all channels, and it writes the example for me, and the example is correct.
I mean, that's obviously a big time saver. It's sort of like going from, getting rid of the TDM, going from a very structured. You need to know the language that it's programming in, but now you're sort of programming it in natural language.
I would never tell anyone have this stuff written in a code that you should have been able to write the code. You're just tired because you've been like taking care of a baby all day, and you're just like, you just don't have that. You have the time, but you don't have that mental, like, that focus flow that you need to write like a lot of intense code. And this is very dense code. It's like you have to get each number for that bit correct, or it's like if you're not addressing the right bit, nothing's going to work. It's going to be very confusing. But if you're just like, I'm kind of tired, but I want to do this, or one thing I have is I have 15 minutes here and there. I can go in and I'll tell it like, okay, do the next one, and then I have to go and do something else in the house, come back, or I have to go to a meeting. It's there waiting for me. So, for example, this library that I wrote was from a few days ago. I have another example sketch I wanted to write. It will have all that context. I don't have to reload the entire context into my brain, which I normally would have to do. And so, like, one of the things that made it hard for me to write these big libraries was like, if I don't do it in one sitting, I'm going to forget by the time I have to update it. So I have to write everything at once. And that's just like, I can't, that's like 5-6 hours. Now it's 2 hours, but it can be sliced up throughout the day, or throughout the weekend, or throughout a month. I mean, I think it keeps context for like a week or two, and you can always regenerate if necessary.
Yeah, I mean, that's fantastic. This is definitely a huge time saver for folks who are doing this. Where can folks go to learn more about how you did this so that they can write drivers like this using ChatGPT?
Yeah. Okay. Let's stop screen sharing. So, number one is we did. So I do want to specify that either everyone is doing this or nobody's doing this. I have tried to find other people doing this, and it's like I have not found any other evidence of folks writing device drivers or this kind of code with ChatGPT where you upload like a data sheet for a chip. So either like this is a great idea or this is a terrible idea. I don't, I'm still working it out. But we did a like 35-minute video on youtube.com, Adafruit channel. And it's called like ChatGPT with writing drivers ChatGPT. And maybe you guys can post the link when you post this up.
I'll do that.
And then also, if you look at on GitHub, so again, when I publish the drivers, which the one I just showed you, I haven't finished, so it's not ready to publish. But let me see, the VCNL one is done. So I'll give you guys a link, and then people can look at in the README. I credit. So you guys can add that link. So in the README for that, I credit OpenAI August 3rd, and also I link to the full script of the OpenAI chat, which I will say is that code. I then massage it. It's like that code is taken is not perfect. Like I have to fix it up. There's sometimes like it has a dash in the wrong place, or like it doesn't remember the function prototype, or it mismatches, or whatever. So that code is not, if you're like, it's not 100% the same. It's like, no, it's not 100% the same, because that's just the skeletal structure that I then can use and tweak to get it totally functional. And you can look at the Git commits to see like, wow, like it didn't pass CI because it needs to have all these things fixed. And that's another thing. It's like, as if I use ChatGPT, like I've never used Copilot before today, so I've not given Copilot credit for any of my code. I just used it today because somebody's like, you should try Copilot too. But as I write drivers and other examples and CircuitPython or whatever Python example code, if I use ChatGPT, I'll always include the chat log so people can see it. I think that's a good way of being transparent about usage of large language models. If you're going to use them, give them the credit. You don't get the copyright, but they do get the credit. And ideally, you also provide the chat listing the way you actually did the work, so people can see how it's done.
That makes sense.
Weird future.
No, I think this is a great use of ChatGPT because it's giving you the framework that you can use to get started on something. It's not perfect, but it's obviously.
But I know that
a lot of
like I know it's hallucinating, so it's like cool.
Yeah, it's. Yeah. I mean, this is what we say to folks who are trying to use it for writing, articles, which we aren't.
It's not so great for that. It's not. It's weird. Whenever I see ChatGPT articles, also you can kind of tell. Yeah. It's got that weird like. Yeah. It repeats words in a weird way. Like. Yeah,
it's right. Exactly. Either it's too creative or not creative enough, or both at the same time, which is a problem. And there's always this thought of like, oh yeah, if humans could just check it enough, it would be fine. But I think it really depends. But what you're talking about is a very highly structured situation.
It's super structured. Like you see me, I am like the guardrails are here. You're going to write this function next, and this is the return value. I am not like trying to. I do not want any creativity. Somebody actually said there's a way to adjust the temperature. And I'm like, and I think I don't adjust the temperature. Like, I don't think I have a setting. I think I just, when I set it up, I am like very specific and terse about how I want it to generate the code. And so it gives me exactly what I want. And then I'm like, good work. We're going to do the same thing, but again.
Yeah.
Again. 50 times.
That's really key because I know it learns from the interaction with you.
Yeah.
So that's really key. I think people are going to get, I think this is a great example of people using an LLM in a very helpful way, as opposed to some of the ways that we have seen LLMs used, like you said, for articles or things like that, where they were trying to get it to do something and it just went off the rails.
I think also like the factual context you set is important. So the context I'm setting is I don't want it to know about the whole world. I'm like, I don't want you to know anything about, except for the libraries I've already written that you're going to write in the style, and this PDF data sheet which contains the whole truth about this chip. I don't want you to go on the internet and like, oh, what do other people say about the INA 3221? Do not care. Do not want them. This is a very enclosed
yeah,
thing,
that's.
but it still needs that overall context of how to write C code. Like it does need all of that and how enumerations work, and how bit shifting works and like casting data. But it's interesting. It makes up many beginner mistakes, so you have to have an eagle eye.
Yeah, no question. But certainly, if it's saving you keystrokes, if it's saving you time, and if it's preventing you from making, like, errors that come from data entry, like you said, putting in the wrong.
I think it's less errors actually, because I'm still doing the code review, and doesn't do copy and paste the same. It doesn't have the same kind of copy and paste errors, and I'm more paranoid in looking at it. So far, it's made fewer mistakes than if I had done it or if somebody who I was working with. Like, I mean, I review other people's code. Humans make mistakes too, not just LLMs.
No question.
Yeah.
No question about it. Well,
okay.
We know you're a busy person.
I know.
You've taken up a lot of your time. Thank you so much for talking to us about this.
Thank you very much.
This is really please folks check out the video on YouTube, on the Adafruit YouTube channel, and we'll be linking to it.
Yeah, and if people have suggestions on like how to use this tool even better, like people have all these tips and tricks, post them in the comments to this video or article where it comes out. Like, how are you using ChatGPT as part of your engineering practice? I would love to learn. This is like another tool in our toolbox.
Yeah, really cool. Well, thank you so much.
Hey guys, Ash here. So for those of you who don't know, we cover Raspberry Pi projects all week long at Tom's Hardware. And at the end of the month, I like to take at least 10 of them and put them together in a list. We call it the best Pi projects of the month, but really they're all great. And I have a hard time picking 10. So what I wanted to share with you guys today is just a little sneak peek at that list. You can find all 10 of them over at tomshardware.com. But for right now, let me show you some 3 that I thought were particularly cool. So, Les, have you seen the movie Interstellar?
I have, yes. A long time ago, and I like it.
So there's this robot in that movie, I'm sure you remember. For those who haven't seen it, it locomotes in the most interesting fashion, and somebody has actually recreated this robot. It's called TARS, and it's got a Raspberry Pi inside, because isn't that fantastic? And you can see it's got these 2 big pillars on the side and a pillar in the middle, and it will scoot itself by pivoting that middle, pivoting itself around that middle pillar. And it's just incredible to watch this thing in action. I mean, I've never seen a robot move like that before. You'd think it was just some CGI stuff, but the maker behind this particular project, they had to really get creative to work out the logistics of how to scoot that middle pillar around without it dragging on the floor, without it being too heavy.
Yeah.
And this is an earlier version of it. That's why it looks a little different, but do you want one or do you want one?
I would like one. It's interesting design because it doesn't move how we expect a robot to move. We normally think of wheels like R2-D2, like treads, or to be bipedal like C-3PO, or something like Boston Dynamics, where it's got 4 legs and it runs around scaring us all to death. But this thing, it's like 3-legged walks. It's like a Monty Python sketch. That if anyone remembers that, I do, a mold. It's just interesting how it looks and how it moves. It's completely mind-blowing how you do it.
Like the fact that they made it work. You know, it's one thing to see something like that in a movie, but for someone to recreate it outside of that environment and then have to work out the details on their own. It's not like they had a team of people from the movie helping coach them on how it's supposed to move. They had to just, trial and error, 3D print a few pieces, tweak this, tweak that, until it scooted along the way it's supposed to.
It's awesome.
So then,
I like that.
The next project I wanted to share is this. We've covered something similar before. We've had Ryder Damon on a few times, and I think we actually had him write an article for us on how to create a voice assistant in an old rotary phone. But what's fun about this version of that is they're using ChatGPT to change the output of the assistant so that it has a German accent, which I don't know why that's amusing. I think it's just a fun idea to give your voice assistant a little bit of personality, splicing in a little bit of ChatGPT to make it happen.
Yeah.
And so I thought that was pretty fun. And of course, you can check out, if you want to make your own, you can check out our guide that Ryder put together on how to create your own rotary phone voice assistant. I just like the idea of maybe you have some friends over and they don't know that you have this phone, and then suddenly you just pick it up and you're like, Google, dim the lights, and hang up, and then the lights dim. They're like, who are you talking to?
Yeah, I mean, it's old technology now. We're picking up a handset like that and a rotary phone. It looks so out of place now in our life, where we've got black slabs of glass and plastic in our pockets all the time. It's interesting way to interact with the world around you.
It really is merging two different eras, isn't it?
Definitely, yeah. Retrofuturism. That was something coined by Sid Mead, the designer of Blade Runner.
Oh, cool. So one more project. I'm biased. I picked this one because I like it. I don't know if everyone else is going to be as excited about it as me. Les, this is out of your wheelhouse because I grew up in the Pokemon era, and I mean, it was pretty big back then, and it's like ingrained, like all the intros are ingrained in my head for probably forever. But this maker is using a Raspberry Pi on a legit copy of Pokemon running on the Switch. I think they're using either Sword and Shield or the new Diamond and Pearl remakes that they released. But the Pi is looking for what's called a shiny Pokemon. And if you're not familiar with that, those are Pokemon that are just colored differently than usual. And they have like a really low spawn rate. And even if you find one, catching one, it might not happen. You might have just seen it and then it gets away from you. So this maker is using a Pi to hunt shinies for them while they're asleep. It just starts battles over and over and over. And it's able to detect when a shiny appears. And then it throws a Master Ball to catch it. And that's where this might get a little bit controversial, because the Master Ball will always catch the Pokemon without fail. That's why the games always put 1 in the game. So as you saw by the screenshot, there were 4 of them. So they used a dupe hack on another Pokemon game to get a whole bunch of Master Balls. So whether or not you want to do that, it's up to you. But I think it's a really cool proof of concept that they're able to hunt shinies with the Raspberry Pi, and then you can have a whole team of shinies and impress your friends until they notice, hey, how'd you get 6 Master Balls? That's cheating.
So I heard someone the other day, they were walking around a local park and they were talking about Pokemon shinies. And I think they were doing Pokemon Go, walking around the park, capturing them. And they said out loud, oh, I've got a shiny. And I knew exactly what they were talking about due to that article. But that's all I know.
So those are the 3 projects I wanted to share to get you guys excited. There's cooler ones than that on there. Well, again, I don't like ranking them because a lot of like your opinion on Pi projects is going to be subjective. I think they're all really cool, but there's ones that are just as cool, if not more cool, on that list. Go to tomshardware.com, check it out, and if you make something cool, send it to us because we like cool stuff that people make with the Pi.
Definitely. Thanks very much.
What's the best place if somebody wants to reach out to us and send us a project they made? What's the best place for them to do that?
It'd be my email address, les.pounder@futurenet.com. And I'll put that somewhere in the comments and description.